The Bronsted-Lowry theory of acids and bases relates specifically to the transfer of protons. So the main advantage that this theory has over the Arrhenius theory is that this does not necessarily have to be in the presence of water where these reactions would happen. So by the Bronsted-Lowry theory, it says that an acid is a proton donor. When we speak about a proton here, we are speaking about a hydrogen ion. And so we can see that an acid is a proton donor in the following reaction, where we start out with hydrochloric acid and we react that with water. We know in the Arrhenius theory we have called this process ionization. And what we show here is we show that the hydrochloric acid donates its proton to the water molecule, thus leaving a chlorine ion, as well as creating a hydronium ion. So you can see here that the result of the Bronsted-Lowry theory is the same as in the Arrhenius theory, but the explanation for how that has happened is slightly different. In the same way, we can say that a base is a proton acceptor, and what we can do here is we can show that this is possible with ammonia when it reacts with water, because we can see that the ammonia is able to accept a proton from the water molecule, which means that the ammonia becomes NH4 with a positive charge, and that is aqueous, and it leaves hydronium or hydroxide ions behind. So once again, the result of this reaction is the same in that it produces hydroxide ions. So by Arrhenius theory, it is also a base, but the explanation for why that has happened is different. Where we have said in Bronsted-Lowry theory, we're talking about the transfer of protons, where an acid is anything that can donate a proton, and a base is anything that is willing to or able to accept a proton. You will see here that water is able, in this case, since the hydrochloric acid is our acid donating the proton, that makes the water the base. And in this case over here, since the water is donating the proton, that makes the water the acid and the ammonia the base. And we call that property an ampholyte. We say that water is an ampholyte because it is able to act as both an acid and a base.